Okay, so number 41 on page 524. And it says a 12.5 gram bullet is shot into a ballistic pendulum that has a mass of 2.37 kilograms. Okay, so now you might say, what the heck is a ballistic pendulum? It's simply a pendulum that they use to study the ballistics of a bullet. So there's a whole area of science that studies ballistics. It's like how deep will the bullet penetrate? What kind of damage does it do? And if you've ever watched shows like CSI or what was the other one that used to be on where they would always do all this analysis? Okay, so it's just a block of wood that they're firing a bullet into to see what happens. Okay, so we do not know the initial velocity of the bullet. That's what we're looking for. But it says after the bullet hits the pendulum, it sticks in the pendulum. Okay, so it stays embedded in the pendulum, and then the collision causes the pendulum with the bullet in it to swing up so that it reaches a maximum height above where it was of 9.55 centimeters. And the question is, well then what must be the initial velocity of the bullet? Okay, so the first step is figuring out what are your parts. Well, there's the part where the bullet hits the pendulum. That's a collision. It's momentum, because it's a collision. And then there's the part where the bullet pendulum system swings up. It changes its height. And so that is energy. And as you were trying this one, the first one on your own, you probably started here then and said, okay, momentum. So mass of the bullet, initial velocity of the bullet, plus mass of the pendulum, initial velocity of the pendulum, should equal mass of the bullet plus the mass of the pendulum, final velocity, because they stick together. And the pendulum's not moving initially, so this goes to 0. And then you'd be like, okay, I need to find the initial of the bullet, but wait, I don't have the final. So you have two unknowns. And you'd be like, and then you could give up. Or you could say, I must not be able to start here. Which actually makes sense, because if you could start here and find the initial velocity of the bullet, then you wouldn't need to use the energy at all, and that would just be sad. So go over here to energy. 1/2 mv initial squared plus mgh initial plus 1/2 kx initial squared is equal to 1/2 mv final squared mgh final 1/2 kx final squared plus E lost. Okay, there's no spring here, so both initial and final go. It says nothing about E lost, so it's gone. At the bottom, just before it's about to swing up here, does it have a speed? Sure it does, because if it didn't, it wouldn't swing up. Does it have a height? No, usually we call the height down here when it's about to swing up 0. Finally, it's going to go up until it stops. No speed. And this is our final height. So speed goes, we have height. So we're left with 1/2 mv initial squared is equal to mgh final. Now, what are the m's? Initially, the bullet is stuck in the block. Initially, the mass is the two of them together. Finally, the bullet is still stuck in the block. The mass is the two of them together. So the two masses will cancel. We know the height. It was given in the question, so we could find the velocity. Vi squared is equal to 2GHF. 2 times 9.81 meters per second squared. And 9.55 centimeters, you have to change to meters. So 0.955 meters. And remember, that's Vi squared. So after you multiply, don't forget to take the square root. And when you do, you get 1.369 meters per second. If you got 1.8737, you forgot to take the square root. Okay, so this is the speed with which the bullet and pendulum begin to swing up, which means it's actually the final speed of the bullet pendulum system after the collision. So we now have our VF, So we can now find the initial velocity of the bullet. So it'll be m of the bullet plus m of the pendulum, Vf divided by m of the bullet. Have to be kilograms and grams, so we have to switch one to, I'd switch the bullet into kilograms. So 0.0125 kilograms plus 2.37 kilograms. That final velocity that we just found, 1.369 meters per second. And then on the bottom is the mass of the bullet, 0.125 kilograms. Do the math and get the initial velocity of the bullet to be 260.9 meters per second, which you might think seems crazily big, but that's why you don't stand in front of a bullet, because it is crazily big. All right, number 2, which is really number 42. So in number 42, you have this inclined plane, and there's a cart right on the bottom, and the cart is on an air track. And an air track, if you remember from multiple masses, is like an air hockey table, and what it's trying to tell you then is there's not going to be any friction. Okay, so and a person takes a thing of putty, which is 23 grams, and throws it at this cart. And the cart is 225 grams, so 225 grams. Okay? The whole track itself, this whole thing is 1.5 meters long, and we'll come back and use that later. And it's angled at 25 degrees. The putty is traveling 4.2 meters per second parallel to the track when it strikes it. So when you throw it along the track. So V of the putty initial is 4.2 meters per second. And V of the cart initial is 0. So after the putty hits the cart, it sticks to it. Okay, so here it is stuck. And the cart and the putty go up the track until some point up here where they initially come to rest. So somewhere up here, V final is 0. So what are your pieces? Well, there's the collision here. And remember, collision is always momentum. And then this section is the putty and cart changing height and changing speed. So this section must be energy. Okay? This time they give us the initial velocity, so I'm pretty sure we're safe to start with it. So we can start with momentum, m of the putty, v of the putty initial, plus m of the cart, v of the cart initial, will equal m of the putty plus m of the cart, v final. Cart's not moving, we could find the final velocity of the putty and the cart together. M of the putty, v of the putty initial, m of the putty plus m of the cart. This time I don't have to change them from grams because they're all given to me in grams. So 23 grams, 4.2 meters per second, divided by 23 grams plus 225 grams. Vf will equal 0.3895, I believe. Let me just double check that. Yeah, 3895. Not a really huge velocity. 3895. You need to work on your throwing speed. Okay, so this speed is the speed with which the putty and cart begin to go up the ramp. So now we can go to energy. 1/2 mv initial squared plus mgh initial plus 1/2 kx initial squared is equal to 1/2 mv final squared mgh final 1/2 kx final squared plus E lost. And since it's an air track, no E lost. Alright, at the bottom, does it have a speed? Sure it does. But the thing was right at the bottom, so it doesn't have a height. There's no spring. When it reaches its highest point, it stopped.